All right, so Unit 1B is the second half of Unit 1. Unit 1 was really long and it was solving for X mixed with all of these other random topics that you really need in order to do well with all of the future math and high school math. So, this unit is kind of a little mixture of all these different concepts. Most units are about the same thing, but this one's all mixed up. Um, And so I'm going to just talk about each one and talk about how it could get harder. So, what is a function? This one is just about determining if something's a function or not. And honestly, you're seeing it at the hardest it will ever be. Um, yeah, x and y intercepts was also a part of that same what is a function lesson. And this concept will show up for the rest of math. And it'll keep getting harder every single time you do a new unit. You're going to see x and y intercepts in a new way. So it would take way too long to explain how it gets harder. It just you'll continue to see it. So when it comes to multiplying binomials, remember a binomial meant that there are just two terms being multiplied. Um, Now we're going to talk about multiplying polynomials if there's more than one being multiplied. And we're going to do it with area and perimeter because these concepts went together. Um, so in order to make this easier, the first thing I'm going to focus on is the fact that my length has a exponent on it to the power of 3. And it's going to be kind of hard to multiply this to this when this one is stuck in a way where it's simplified. Because you can't multiply this to this since this one's stuck in an exponent of 3 and this one's not. Therefore, in order to do this, I'm going to want to multiply this all out into an expression that does not have an exponent on it, because this one doesn't. So I'm going to do that first. So remember the exponent of 3 means what? Means I'm going to have 3 parentheses getting multiplied together. So, in my opinion, it's easiest to start with just 2 of them. And then I'll think about the third one later. So remember to do this. First, I'm going to take this first term, this x, and multiply it to the first one in the next parentheses. And x times x is squared. Next, I'm going to take that same x and multiply it to the next term in my parentheses, which is -2. And -2 times x is. My next step is I'm going to want to take so this first term went to everything in my next parentheses. So now the second term in my first parentheses needs to go to everything in my second parentheses and it has to multiply to both of them. So then when I do -2 times x for this one, I'm going to get another -2x. And then when I do -2 times -2, I'm going to get +4. At this point, it's always good to combine like terms and simplify because I have 2 x terms in here. I have this -2x's and this -2x's. When I combine -2 with -2, I get -4. So I still want to keep my first x squared. And I have -4x plus 4. So that was only 2 of them though. And my original expression had 3 parentheses. So it's not, this was the first 2. So this expression was the same as these 2. But I still need to multiply the third one in. The process is the same. I'm going to take my first term in my parentheses, which is x squared, and multiply it to the x term because it's the first one in the next parentheses. X squared times x is the power 3, x cubed. Then x squared times -2 is -2x squared. This first term in my first parentheses went to both in my second parentheses. Now I have to take my negative 4x and multiply it to both terms in my second parentheses. So let's see. Negative 4x times x is what? Negative 4x squared. Negative 4x times negative 2 is what? All right. And now, so I did this one to both, that one to both in my second parentheses. Now I have to take this plus 4 and multiply it to both. So 4 times x and 4 times negative 2. So 4 times x is x, and 4 times negative 2 is negative 8. So we're almost done, except I have to combine any like terms I have, and I have a ton. So this x to the power of 3, or x cubed, it's the only one. So I'm just going to retype it, the 1x cubed. But now my minus 2x squareds minus 4x squareds combine to negative 6x squareds. Then I have two x terms. So here's 8x's right here and 4x's right here. So altogether I have 12x's. And then my number term at the end is just minus 8. There's no one to combine with, so I just end it with negative 8. So all of this is to say that my length is the exact same thing as, I could delete this and replace it with what I just solved it to be equal to. So now I can put this all in a parentheses because it's one whole side. I'm going to delete this work. So if I wanted to do perimeter, what's the rules? How do we figure it out? You add up all four sides. So this is one side. And I'm going to add it. We don't need the parentheses for adding. I'm going to add it to the next side. So when you have a square and you need to add all four sides, adding the length once is enough because it will also be on the other side across from it. So I have to add it once and then add the width once and then add the length again for this side and then the width again. So because of that, I need to add all of this all over. So I'm going to highlight it all and just copy it. And then at this point, we'll just combine our like terms. So how many x cubes do I have? Here's one. Here's another. So I have a total of 2x cubes. And x squared, negative 6, plus 2, minus 6, plus 2. It's going to be negative 8 x squared. And if I did just my x's, here's 12 plus 3 is 15 plus 12 plus 3 more is a total of 30 x's. And then my just numbers, minus 8 is negative 16. And then that would be my final answer for perimeter, this guy right here. Then if I wanted to do area, find the area of a square, I do what? I do length times width, so I'm going to want to multiply the length times the width. And multiplying is the same process as before, where each one of the ones in the first parentheses have to go to each one of the ones in the second, even though there's more of them. So then I'm going to do x to the power 3 times 2x squared and get what? 2x to the power of 5. X to the power of 3 times 3x is what? Positive, so plus 3x to the power of 4. I'm going to take the negative 6x and times it to positive 2x squared to get negative 12 x to the power of 4 and negative 6x squared times positive 3x. Negative 18x to the power of 3. Now I'm done with the 6, negative 6x squared. So then I'm going to focus on the 12x and multiply it to both of them. So 12x times 2x squared and 12x times 3x. 12x times 2x squared is 24x to the power of 3. And 12x times 3x is 36x squared. And finally, I still have to do that negative 8 and multiply it to both of those. So negative 8 times 2x squared is negative 16x squared. And negative 8 times positive 3x is negative 24x. And then I am almost done because I always have to end by combining like terms. So this x to the power of 5, this is the only one. So there's 2 x's to the power of 5. For x to the power of 4, there's 3 here, minus 12 here, becomes negative 9 x to the power of 4. For the power of 3, here's negative 18, plus 24. It's positive 6 x to the power of 3. 36x squared minus 16x squared becomes 20x squared, positive 20. And then the just x's, there's only this minus 24 x's at the end, so there's no one to combine with. We just copy it. And then that would be the answer for the area. All right, for evaluating functions, some ways that we can make it harder is for equations, it gets harder when the types of equations get harder. So I introduced you to a few of them with the x squareds and the x cubes and the some of them, but they can continue getting harder the more and more type of equations you learn. For graphs and tables, one thing is that you can have more than one answer or no answer at all. For example, when this says f parentheses 2, what is the 2, the x or the y? It's the x, and what it equals is they want you to tell me the y. So when I go to where x is 2 on this graph, and then search up and down for my y, there is no graph here. There is no answer. For this one, they want to know what x is. So they want to say x when f of x, the answer, equals 1. So when y equals 1, because f of x is just y, when y equals 1, what's the answer? What's the x? Well, if you look, first of all, right here, this point has a y of 1, and that x is negative 1. So one of the answers might be, here, I'm going to do it in a couple, is when x is negative 1. So when I go to x is negative 1, it goes up, the answer is at 1. But also look, when x is positive 1, that also has an answer of 1. And later on, when x is 4, there's also a graph where there's an answer of 1. So sometimes there's no answer because there's no graph, or sometimes there's a bunch of answers. In a table, for example, you might see here they want to know what x is when f of x, remember f of x just means y, when the answer is 5. So then if I look at my table, here's one point where the x answer is 5. So I can say when x is 1, the y going with it was 5. Also later on, when x was 10, the y was 5. So that's in a table how you might have more than one answer. If I said when x was 3, you couldn't tell me because this table doesn't have a 3 on it for x. And so that's when you'd say no answer for a table. They can also make this harder, this evaluating functions, by asking you to figure out a pattern. So I've changed them up a little bit. And for this one, they want to know what the graph is, the answer is going to be when x is 6, because f of x, or f of 6 with the 6 in the parentheses means that x is 6. When I go where x is 6 and go up and down, I don't see any graph. However, I do see an arrow pointing, which means this is going to continue. Which means if I continue this pattern, if I went back one, do you see how the drop went down exactly one whole square like that? So this one's up here at 2. One before it, when x is 4, it's at 1. So then if I continue this difference of 1, it will go up here. So when x is 6, the answer is going to be 3. Up here on this one, it didn't have an arrow. And also there's nothing where this 2 would go. Like this one doesn't have an arrow, this one doesn't have an arrow. So you can't guess. You would just have to say no answer. Versus down here, because of the arrow, they're expecting you to be able to guess. Up here on this table, you also can't guess because there's no pattern. So if I go from 1 to 4, that's adding 3. 3 more is 7. 3 more is 10. So my x's right now are going by 3. And so they have a pattern. But then if I watch my y's, are they going by something? Well, from 5 to 7, that's up 2. Up 2 more is 9. So it looks like it's going up by 2, but then it gets to this 5, and that's not 2 more up. So then there's no pattern because one of them messed up. And because there's no pattern, I cannot guess. So if I were to ask you one of the ones not on this table, you cannot make a guess. However, if there is a pattern, so this is almost the same one. So because it's only almost the same one, we know x's are going up by 3. And the y's, this time they are going up by 2. Because 5 plus 2 is 7, plus 2 is 9, plus 2 is 11 this time. So if I say what's f of 13, because the 13's in the parentheses, that means it's the x or the y. It's the x, and they want to know what the y will be. So if I were to add in a whole nother point where the x was 13, is it following the pattern where it's going up by 3? It is, because 10 plus 3 more is 13. Which means, following that same pattern, my y needs to go up by 2. And if my y goes up by 2, the answer is, so f of 13 would equal 13. All right, for domain and range, there's a lot that can make it way more complicated. This is something else that you're going to see throughout the rest of your high school math. So remember, domain is all of the what values. It's all of the x values. Okay? And so just starting with domain alone, this one's really confusing because there's 2 different equations on it in 2 different colors. They don't connect. There's weird holes and there's dotted lines that you've never seen before, at least not in the first lesson. So here's how it works. Remember with domain, you always start on the left. And on the left, there is an arrow that is going up, but up and down's range. This arrow is also kind of going to the left, but then it kind of looks like it gets stopped at this dotted line. If this dotted line wasn't here, we would have said that negative infinity was the bottom of your domain because it would have been going left forever. However, this dotted line is something called an asymptote. And this is how you spell it, asymptote. And an asymptote is a line that you can get really, really, really close to, but you can never touch it, which means on the x's, there is not a point at -2. Like if I go up and try to touch it, it looks like it's going to touch, but it doesn't because that's what an asymptote means. So it almost touches -2. It just doesn't actually touch it because it's an asymptote, which means I cannot include -2. I would not put the equal to sign down here because it's not including it. Well, then right after -2, there's a graph. The graph is going left to right. The graph is going to continue all the way till right here, and then it's stopping. Where is it stopping? When x is 1. You see this x right here because it's about the x's. So the x's are stopping at 1. Now, normally, if that was a closed dot, I would put this little sign to say that it is all my x's for this green part is less than 1 or equal to. But this open dot means I cannot include it. It's another reason I cannot include a number. Because before I said the only thing you cannot include are infinities. Because you can't really include an infinity because that's just a concept, right? Like it just means forever. It's not a real number. However, now there are numbers that cannot be included because if there's an asymptote, it means you can't touch it. So you can't include it. And an open dot also means you cannot touch it. You get really close, but you cannot touch that number. So then I also would have to put just the less than sign. So this would be my domain for the green one, because this green one goes from when x is -2 to when x is 1, just not including either one of those actual points. But then you also have a whole nother little part of your graph later on. So nothing's happening between 1 and 3 for the x's. Like if you look up and down, there's no graph there. However, starting right at 3, there's a point. And that point is included. There's an actual real dot at 3. It's not an asymptote. It's not an open dot. It's a closed actual dot, which means I have to say it's all my x's are less than 3 or equal to 3. And then what's the upper end? Well, this graph keeps going all the way. Oh, there's an arrow. So it's going to actually keep going forever. So it's going to go until infinity. However, remember, we cannot include infinity. So I'm just going to say less than because you cannot equal infinity. So you don't want the equal sign underneath. Infinity. All right. So because this graph is split up, non-continuous, meaning that there are multiple ranges. So it's not continuous. It's not like you can draw the whole thing without lifting your pencil. You'd have to lift it in order to draw this graph. So it's not a continuous graph. It splits up, which means that it has multiple ranges. And so there's 2 domains because at least with the x's, it got split up. However, with the range, there are not 2 ranges. Remind me, what is range? All of the what values? Range are my y values. So you're going to have the 2 ends. So what's the lower end on y? Because y's go up and down. And so how far down do these graphs go? The furthest down, so if I start all the way at the bottom, there's no graph down here. If I start moving up, the first points I see for both of them are right here at when y is 0. They both start on the x-axis, and here y would be 0. And they both have points there, so they're not just less than 0, they can also equal 0. So I'm going to use the less than or equal to 0. And then as I start going up, there's points everywhere all the way forever and ever because this arrow is going to keep going up. So it's just going to keep going up forever. There's no part in the y's after 0. From 0 up, there will always be a y value. Like when y is 1. Look, those are points. When y is 2. Look, here are points. So it's going to go up forever and ever all the way to infinity. Can I include infinities? Should I have an equal sign under this? No, I should not. And so that is my range. One thing to note is that even though there's an open dot here when y is 1, there are other places where y is 1, like back here and over here, um, where there are closed dots, like connected points. So the range still includes 1. There's no need to have like a split or anything like that.